Hey guys, well today we're going to talk a little bit about plate tectonics. And when you look at plate tectonics, the Earth can be broken into basically giant surfboards. And when you think of giant surfboards, you're like, well, wait a minute. That means we actually have to be floating on top of something. Well, we are. We're actually floating on top of a giant sea of magma. Well, what's the difference between magma and lava? Nothing really. It's just a term. Magma is what's underneath the Earth's surface. Lava is when it comes to the top. Science always has a funny way of just identifying the same thing with a different name. Today we're going to do another demonstration. Our flat Rice Krispie treats are going to represent oceanic crust. Our large regular Rice Krispie treats are going to represent continental crust. The lithosphere, where we find most of our crust, well, oceanic crust is thin. That's why it's thin. Continental crust is nice and thick, which is why these Rice Krispie treats are normal. When you look at plate tectonics, it can be broken down into three different categories. You have transform boundaries, divergent boundaries, and convergent boundaries. We're going to demonstrate the difference between what happens with both of these when you have just regular oceanic crust hitting, continental crust hitting, or a combo of the two. So let's start with our oceanic crust. So here we have two plates sitting happily next to one another, but forces within the Earth obviously are going to make things move. Again, ocean currents don't stay still. Well, magma currents don't stand still. When we looked at hurricanes, we saw the idea of convection currents. Well, that's going on inside the Earth's core. You have constant rotation of the magma as it heats up and cools underneath inside the Earth's core. Well, as this heating and cooling is taking place, it's moving the plates. That's why we sort of just float there. And so as oceanic crust separates and starts to move apart, the magma comes up and that creates new land. Or you get a ridge. It's called an ocean ridge as these oceanic plates move apart. A case in point where we see a big ridge is actually the Atlantic Ocean. The Atlantic Ocean has something called the Mid-Atlantic Ridge because there's a ridge right in the middle of the Atlantic Ocean. But as the Atlantic Ocean separates, it's actually getting bigger. And one place where we see this ridge separating and growing new land constantly is Iceland. Iceland is growing. If you want to invest in real estate, I highly recommend Iceland because, well, you get new property and it expands. In 2011, they had all of the volcanic eruptions. Well, that was because the plates were moving. And when you look in terms of oceanic crust, as it separates, new land comes up, and that's how you get. These are called divergent. They're moving away from each other. These are diverging away from each other. Now, in the case of two continental crusts, diverging or moving away, typically, yes, you should have magma coming up, but again, size difference. Is it better to have a chance of magma coming up from an oceanic crust versus a continental crust? This is more your chance. When you have the case of two continents separating, typically what happens is ocean fills in. When we look at Africa, which is why we're studying Africa anyways, African geography is a perfect example of this, where you have two continents separating. Well, wait, Africa's still together, but there's remnants of when India pulled away from Africa, and there's still lasting scars from when this happened millions of years ago. As India pulled away from Africa or diverged, Madagascar was ripped off, which is why Madagascar is no longer attached. When you look at the Great Rift Valley in Africa, that's a scar from when India broke away. So in the case of continental crust pulling apart, that is something that we typically see. Now, when you think of other continents that diverged away, well, if you look at South America, it fit perfectly right into Africa. So you can see right where they used to be. So as they pulled apart, the Atlantic Ocean filled in. Connecticut used to be part of North Africa. We used to be part of Morocco. It's weird, but it's true. Now, let's take a look at our next plate boundary. Typically, when you have two plates converge or smash together, you get mountain chains. Well, you're probably thinking, well, how does that really work? Well, here it is. Two continental crusts moving along, moving along, moving along. And as they push into each other, well, they're both so dense that they can't do anything else but move up. And there you have it. You now have a mountain. So if you look at all of your major mountain chains in the world, the Himalayas, the Alps, the Andes, the Rockies, the Atlas Mountains, all of these mountain chains were all created with this concept. Two continental crusts smashing into one another, creating mountain chains. And going back to India, well, when India smashed into Asia, that created the Himalayas. India is actually shrinking. I'm getting to that in a moment, though. Now, when you look at two oceanic crusts, now they're both so thin that whichever one runs into each other, you don't really get a whole lot of mountain chains because they're not dense. What actually ends up happening is one plate begins to go under the other. Whichever one is a little bit thicker is going to win. And this is known as subduction. Now, subduction is when one plate goes down and it actually goes back into the Earth's core or the mantle, and it actually begins to be recycled. It melts. And this is where you typically find volcanoes. Now, same thing. When the ocean's crust pushes into the continental crust, it subducts or goes underneath. Because look, the continental crust is so thick, it can't go over it. It can't run into it. So as the oceanic crust goes underneath the continental crust, it subducts and it gets recycled. And you get volcanoes because, well, all that extra dirt needs to go somewhere and it's being recycled. So where you find most of your world's active volcanoes is typically a subduction zone. So if you look at the Ring of Fire, that's the whole Pacific Ocean outline. So that's where your most active volcanoes are. It's a subduction zone. You find a few more subduction zones in the Caribbean. You also find active subduction zones, again, in parts of the Pacific Ocean mainly, and even parts of South America. But typically they call the Pacific Ocean the Ring of Fire for a reason. It's an active subduction zone. Now, our final plate boundary is not one that you typically think about, but California is the perfect example of a transform boundary. This is where two plates are actually sliding past one another. So there's so much friction, it's like rubbing two pieces of sandpaper together, and finally when one shifts, it actually goes past it. Now, well, what's the big deal? Well, the big deal is, well, that's oceanic crust. Doesn't matter if it's oceanic crust or continental crust, same effect happens. When this plate shifts, it moves the landmass, usually feet, not in inches. So when you look at the 1906 earthquake in San Francisco, well, when that hit, California is on a transform boundary. The San Andreas Fault is a transform boundary. So eventually California is going to break away. When you look at the Great Quake in 1906, the only reason they figured out it was a transform boundary is a farmer had just put in a new fence. And when the quake hit, he went out the next morning, the fence moved 6 feet. He's like, well, wait a minute, I didn't put it there, but the entire piece of fence moved 6 feet. Now, go to 2012, 2011, when the earthquake struck Japan, or was it 2015? Either way, when the earthquake struck Japan, the entire country moved 11 feet. So its GPS didn't match anymore. The entire country moved 11 feet. Think about that. A country moved 11 feet. That's mind-boggling. But going back to the whole idea, oceanic crust, continental crust, you have 3 types of plate boundaries: transform, they slide past each other; diverge, they move away from each other; and converge, they smash into each other. And as a result of all of this, you get earthquakes, you can get tsunamis. Now remember, a tsunami is only created by an underwater earthquake. So when any of these plates move underwater, it's like falling into the bathtub. You create a big wave because the things moved. Well, that's the same concept. Earth moves underwater, creates a giant wave. So hopefully you enjoyed this demonstration. If you have some Rice Krispies at home, feel free to demonstrate yourself. All right, have a good one.